In this video, we'll be looking at the theorems for triangles, angles. And there are three that we're going to look at today. The first is the interior angle sum. Simply put, the sum of the interior or inside angles of any triangle is going to be 180 degrees. And in the problems that we're about to look at, that's the way we'll approach them. The exterior angle sum is always 360 degrees. And as we work on those problems, we're going to see the same sort of techniques used, it's just the number is different. And then finally we're going to look at remote interior angles, and the correct phrasing on that is that an exterior angle is equal to the sum of the remote interior angles. But rather than just explaining it to you, I'd rather show you with pictures, and those will be the last ones that we look at today. So the interior angle sum. If we have a triangle here, and one of the first things that you should always remember when you're looking at situations like this is nothing is ever drawn to scale. That means even though an angle might look a certain way, it may not be accurate. I can tell you that this is going to be a 40-degree angle. Now I don't know if that is the case for the actual triangle that you're looking at, but for our purposes we're going to call it a 40-degree angle. I can also say that this one is a 60-degree angle. So the question I'll ask is, what is the remaining value? Simple enough. Like I said on that first slide, the sum of all of the interior angles of a triangle is always 180 degrees. So what we're saying is that 40 plus 60 plus this x, whatever that is going to equal 180 degrees. Combine like terms. 100 plus x equals 180. Subtract 100 from either side, and we find that x equals 80 degrees. Fairly simple, I think. So let's move on and do another triangle. This time let's change it up a little bit. We're going to make this angle simply be x. And we're going to make this angle twice as big. We're going to call it 2x. And then finally, we'll take a look at the last angle, and we're going to call it 3 times as big as the first one. It's going to be 3x. What's the measure of each angle of the triangle? Well, the same rule that we just talked about still applies. The sum of all of the interior angles of a triangle is always 180 degrees. So x plus 2x plus 3x equals 180 degrees. Combine like terms. We have 3 plus 2 plus 1, or 6x equals 180. Divide both sides by 6, and we find that x is 30 degrees. Hey, that's wonderful. We now know one of those angles. We know this one, but we still don't know the other two. Well, if the first one is 30 degrees and the second one is 2 times x, 2 times 30 would be 60 degrees. And then finally the last one, 3 times 30, that's 90 degrees. And if we add these three numbers together, you do get 180 degrees. So those three numbers are the measures of the three angles in that triangle. So let's do one more involving interior angle sum. This time, let's involve a variable, but not on all of them, just on one. Let's make this first angle, let's say this one will be an 85-degree angle. I know it doesn't look like an 85-degree angle, but like I said earlier, we always go by what's written, not by what it looks like. That's called not being drawn to scale. And we'll make this angle over here we'll make it 25 degrees. And finally, this last one, we're going to make it 4x degrees. What's the value of x? What's the value of this angle right here? Well, we're going to find both of them. Once again, the sum of the interior angles is 180 degrees. So 85 plus 25 plus 4x equals 180. 25 and 85 added together will be 110 plus 4x equals 180. Subtract 110 from both sides, and we find that 4x equals 70. So x apparently equals 70 over 4, which reduces to 35 halves. And if we want to plug 35 halves back into this original statement, we find that the measure of that angle is 70 degrees. So I can write the answer this way: 70 degrees and x equals 35 halves. Let's just put a comma in between to make sure that it's clear, and I'll put a nice box around it. So that's how interior angle theorem works, which is very similar to the exterior angle theorem. Now with the exterior angle theorem, first we need to define an exterior angle. Notice on this triangle, I extended each of the three sides past the vertex. This one went past the vertex, this one did, and that one did as well. The exterior angles are the acute angles, all tracing around in a single direction. And the sum of those angles is always going to be 360 degrees. So, and excuse me, I call those acute. They're obtuse in this case. They can be either, really, depending on the triangle. But if I wanted to make this one 100 degrees, kind of looks like a frowny face, and I wanted to make this one also 100 degrees, what would be the measure of the remaining exterior angle? Same rule applies for interior. The only difference is that the sum, instead of being 180, is 360. 100 and 100, that's 200 plus x equals 360. Subtract 200 from either side, and we find that x equals 160 degrees. Pretty simple and very similar to the last one. So why don't we go ahead and use a similar problem. Let's say that this exterior angle has a value of x. This exterior angle will have a value of 2x. And this exterior angle will have a value of 3x. What are the measures of all three angles? Well, the setup is almost identical to the last time we looked at a problem like this. We take the three values that we're looking at, but instead of them adding up to 180, they add up to be 360. We still combine like terms to get 6x equals 360. And when you divide both sides by 6, we find that x is 60. So, as I start writing down the answers, we know that that angle right there is going to be 60 degrees. Double that to find this angle right here, which is 120 degrees. And triple it to get this angle right here, to get 180 degrees. And those are the three angles that are exterior to this triangle. And let's do one more before we move on to that last theorem. This time around, just like with our first set, let's just leave one variable in this. We're going to say that this one will be 115 degrees. We'll make this one up top 105 degrees. And this one on the bottom, we're going to make 3x. What is x? And what is the value of that angle? 115 plus 105 plus 3x has to be 360. Combine like terms. We're saying that 120 plus 3x equals 360. Excuse me, that's not 120, that's 220. Subtract 220 from both sides, and 3x equals 140. Divide both sides by 3, and x, and I'll go ahead and just leave it as an improper fraction, as 140 over 3. Now the factors of 140 are 2, 2, 5, and 7. There is no 3 involved, so we can't reduce that fraction any. So there's our value for x. If you plug this into 3x, you're going to get that the missing angle is 140 degrees. And those are the two answers we're looking for this problem. So now let's move on to the last theorem, remote interior angles. Remote interior angles states that an exterior angle, this one right here, we'll call this one x for exterior, is equal to the sum of the two remote interior angles. Now there are 3 interior angles. The word remote means far away. You have a remote at your house probably. Usually that's short for remote control. It allows you to control your television from far away. without having to get up from your chair. So would you say that this one is remote or far away from the x? No, it's adjacent. They're touching. They're about as not far away as you can possibly get. So the two remote interior angles are going to be this one, I'll call it angle A, and this one, I'll call it angle B. So the remote interior angle theorem states that x equals A plus B. And now that we know that, let's go ahead and apply that in a couple of problems. We'll just do two of them. For this triangle, let's say that we have a 30-degree angle here, and we have a 52-degree angle here. What is the value of this angle x? Well, really simple. It's barely even algebra at this point, because all we have to do is add the two remote interior angles together, and that's going to give us the exterior. 30 plus 52 is 82. X equals 82 degrees. Pretty simple, isn't it? And of course, we can ask this same question from another perspective. I can tell you that this angle is 135 degrees. And I can also tell you that this angle will be 60 degrees. What is the missing interior angle? Well, this time we're saying that 60 plus x equals 135. This time we do have a little bit of algebra we need to work out. We're saying that we subtract 60 from both sides. 135 minus 60 is 75. So what we're saying is that x equals 75 degrees. And if you want to check it, we can see 75 plus 60 is 135. And that is how you apply the remote interior angle theorem.